Then we have what is called linear correlations. Linear correlations are when the points of scatter plot are clustered along a line. We say there is a linear correlation. Properties of a correlation coefficient R, and all this R tells us is how closely resembling the scatter plot is to a line. So, if R is between -1 and 1, that's one property. If R is greater than 0, there's going to be a positive correlation, which means my line is going to go on an uphill slant. If R is less than 0, which is a negative number, it means it's going to end up having a negative slope, and it's going to be going downhill. When the closer the absolute value of this R value is to 1, then that is going to tell you how strong of a correlation there is. So if it's very close to 1, there's going to be a strong linear correlation. If it's close to 0, there's going to be a weak or no linear correlation. So here would be a picture of a strong positive. You can see my line right here, and all the points that were graphed from the particular problem are all clustered pretty much closely to that line. If I look at the next graph, this would be a weak positive correlation. It's going uphill, it's slanting uphill left to right, but see how the points graphed are more scattered about and they're further away from this line? This would be an example of a linear correlation that may have a value closer to maybe 0.75 or 0.8. If I go back and look at this first one, this has a really positive, strong correlation. So I'm going to have an R value, say, maybe close to 0.97. Okay, if I look at this graph now, this has a strong negative. It's going downhill. All the points are clustered pretty much along a line that you can see the pattern of. And this would have a negative R value, and it could have a negative R value that's fairly close to 1, so it could be, say, 0.985. And if I look at this particular picture, this is a weak negative correlation. These points aren't quite as clustered out as what my weak positive were, if that line goes on. So maybe I would say this would have an R value of, say, 0.83. And when we type things into the calculator will calculate these R values for you and tell you how strong of a correlation they are, or how well a linear function represents the set of data. And then if I look at this last one, those points are just scattered all over the place. I can't tell whether they're going uphill or they're going downhill, so there's no linear correlation at all. So this R value is pretty low, and they said if it was close to 0, so maybe this R value would be around 0.1. Okay, the next thing I need to do is hopefully everyone has downloaded the core math tools from self-service. Once you have done so, I need you to open up the program, and you should see a screen that looks similar to this. What I want you to do is I want you to click on that button right there that says Statistics and Probability, and underneath of it, it says Data Analysis. Okay, in economics, and this is a problem we're going to do, a linear model is often used for demand for a product as a function of its price. For instance, suppose Twin Pixie, a large supermarket chain, conducts a market analysis on its store brand of a donut-sized shaped oat breakfast cereal. The chain sets various prices for its 15-ounce box at its different stores over a period of time. Then what we're going to do is use the data from the Twin Pixies researchers project following the weekly sales at the entire chain of stores for each price and obtain the data shown below. So what I've done is I've screenshotted an example of what would come out of a typical textbook. And it says the price per box when they price it at these different values right here on the left column. And then it tells you how many boxes they sold. And it doesn't surprise that when the price was lower, they sold more. What you do from here is once you had clicked on that data analysis button, it should take you to a spreadsheet. And all of these cells are going to be empty. But what I did, if you notice, I entered the first column here and the numbers from the second column in the B column. Once you've done that, you need to start in this upper left-hand corner, drag over and down, and it will highlight everything in both columns. Then what I need you to do is come up here and click on this button right here, which is the scatter plot button. After you do that, you should see a picture that looks similar to this. It has graphed all your pairs for you. So if you notice, when the price was at $240, I sold a little over 38,000 boxes. When it was at $260, I sold a little under 34,000. If looking at this picture, what kind of correlation does this have? Does it have a negative correlation or a positive correlation? Well, pretty much you can kind of see a line that comes down through here, and those points are pretty much clustered around it. So this would be an example of a strong negative correlation. Once you get done with that, what I'd like you to do then is I want you to click on this button here that shows a line drawn through those points. Once you click on it, you will get a screen that looks similar to this one. Or it should look just like this one if you're using this particular set of data. And when you do that, what pops up is the linear regression equation, which is right there. Y equals negative 15,358.929x and a y-intercept of 73,622.5. So remember, the number in front of the x is my slope, and it was negative, which it should have been, and the y-intercept is positive. Lastly, what I want you to click on is this R button right here with a question mark. R equals question mark. And what that is going to do is calculate the R value for this particular set of data. And it'll take you to a screen and it's going to ask you to estimate R. And my choices were negative 9.8, negative 0.78, and I'm sorry, the first one was negative 0.98, the second one was negative 0.78, the third one was negative 0.58, and the fourth one was negative 0.38. Well, the closer it is, when you have a set of data, the closer the points are clustered around a line and tight fitted in there, the higher or the closer the absolute value of that number is going to be to 1. And the one here that best represents this data would be negative 0.98. Because if I take the absolute value of negative 9.8, I get positive 9.8, which is a number very close to 1, therefore indicating a strong correlation. And that concludes our video on introduction of polynomial functions and low or no degree functions and modeling of them.